Hi friends, welcome back to Infra Bytes. In our previous videos, we understood. First one, what a network is. Second one, different types of networks. Now we are going one step deeper into networking. Today, we will understand. First, one network topologies. Second, one OSI model. Third one, TCP IP model. These are the foundation of networking and very important for interviews and CCNA. So let's start step by step. Part 1. Network topologies. First, let me ask you a simple question. We know computers connect in a network. But how are they physically connected? The design or structure of how devices connect is called a network topology. Think of it like a city road map. Different road layouts have different benefits. Similarly, different network designs have different advantages and disadvantages. There are 4 main types. First, one bus. Second, one star. Third, one mesh. Fourth, one hybrid. Let's understand them one by one. 1. Bus topology. Imagine one long cable running across a room. All computers connect to that single cable. It looks like a straight line. When one computer sends data, that data travels in both directions along the cable. All computers receive it, but only the correct computer accepts it. It's like announcing something in a classroom. Everyone hears it, but only the intended person responds. Advantages. First one, very cheap. Second one, easy to set up. Disadvantages. First one, if the main cable fails, entire network stops. Second one, performance becomes slow when many devices are connected. Because of these limitations, bus topology is rarely used today. 2. Star topology. Now imagine something different. All computers connect to a central device, called a switch. It forms a shape like a star. Here's the important difference. When a computer sends data, it first goes to the switch. The switch then sends it only to the correct destination, not to everyone. This makes communication faster and more efficient. Advantages. First one, high performance. Second one, easy troubleshooting. Third one, if one cable fails, others are not affected. Disadvantage. Fourth one, if the switch fails, the whole network stops. This is the most common topology today, used in homes, offices, schools, almost everywhere. 3. Mesh topology. Now let's imagine the strongest design. In mesh topology, every computer connects to every other computer. This means multiple paths exist. If one connection fails, data automatically uses another path. So there is no interruption. Advantages. First one, extremely reliable. Second one, very high availability. Disadvantages. First one, very expensive. Second one, too many cables required. Third one, complex to manage. This is used in internet backbone, data centers, military and critical systems. 4. Hybrid topology. Now here's the reality. In real life, networks don't use just one topology. They combine multiple designs. For example, inside an office floor, star topology. Between different buildings, mesh topology. This combination is called hybrid topology. And almost every real-world company network today is a hybrid network. Quick summary. Bus simple but outdated. Star most common and practical. Mesh powerful but expensive. Hybrid real-world combination. Understanding topology is important because it tells us how devices are physically arranged and how data flows inside a network. Part 2. The journey of data, OSI model. Now we come to a topic many beginners are scared of. The OSI model. But don't worry. This is not a theory to memorize. It's simply a step-by-step journey, showing how data travels from one computer to another. Whenever you send a message, your data doesn't jump directly to the internet. It travels through 7 checkpoints. Think of it like sending a courier parcel. Before a parcel reaches a friend, you write back label ship, route deliver receive. Exactly the same thing happens in networking. there are 7 layers. To remember them easily, all people seem to need data processing, application, presentation, session, transport, network, data link, physical. Let's send a simple WhatsApp message. Hello. 7. Application layer, where humans interact. This is the only layer you can see. You open WhatsApp, browser, email, YouTube, and type a message. At this point, the computer just knows. User wants to send data. No network process yet. 6. Presentation layer, the translator and security guard. Computers don't understand text like we do. This layer, first one converts data into machine format. Second one compresses it to reduce size. Third encrypts it for security. Example, when you see HTTPS, encryption happens here. Now the message is safe to travel. 5. Session layer, the conversation manager. Before sending data, devices must agree to talk. This layer, first one starts the connection. Second one maintains the connection. Third one ends the connection. Like a phone call. Hello, can you hear me? If connection drops, session restarts. 4. Transport layer, the delivery service. Now the message is too big to send at once. So this layer breaks it into small pieces called segments. Each piece gets a port number. So the receiver knows which application should receive it. 2 delivery methods. TCP reliable. First one checks errors. Second one resends missing data. Third one used in websites, downloads. UDP fast. First one no checking. Second one used in video calls, gaming, streaming. 3. Network layer, the GPS navigator. Now the data needs an address. This layer adds the IP address. Routers use this to decide which path should the data take, just like Google Maps choosing the fastest route. 2. Data link layer, the local delivery guy. Inside a local network, devices don't use IP to talk directly. They use MAC address. This layer, first one adds MAC address. Second one creates frames. Third one switch sends data to the exact device. So the data reaches the correct computer inside the building. 1. Physical layer, the real world. Now the data finally leaves the computer. It becomes first one electrical signals, cables. Second one light pulses, fiber. Third one radio waves, Wi-Fi. Your message turns into zeros and ones and travels physically through the world. And within milliseconds, your friend receives. Hello. So the OSI model is nothing complicated. It's simply a message traveling through 7 processing steps. Part 3 TCP IP model. Only 4 layers. Application, transport, internet, network access. It combines OSI layers. OSI 7, 6, 5 application. OSI 4 transport. OSI 3 internet. OSI 2, 1 network access. Application layer, user services and protocols. HTTP, HTTPS, DNS, FTP. Transport layer, communication control, TCP and UDP. Internet layer, logical addressing and routing, IP address and routers. Network access layer, physical delivery, MAC plus cables plus Wi-Fi. So remember the golden line. OSI explains networking. TCP IP runs networking. One is a learning model. One is the real-world implementation. Today you understood how data actually travels, why layers exist, how internet communication works. In the next video, we go even deeper. We will see how data is packed and wrapped, using packets, frames, and encapsulation. And that's when networking finally starts making complete sense. This is Infra Bytes. See you in the next lesson. Day 3. Thanks for watching. Please subscribe the Infra Bytes channel, like, share, and comment.